Entropy, sometimes they're going to ask you to do a calculation. Sometimes they just want you to make an educated guess as to whether the entropy in the reaction is increasing or decreasing. So you can make a judgment. And it's quite easy to do this. Normally this is a couple of marks, yes or no, increase or decrease, as to whether the entropy of a reaction is increasing or decreasing. Simply by looking at the number of particles and their state symbols. By looking at the number of particles on each side of the equation. And their states. So the key thing, look for changes in state. If I'm making a gas, that can only be a good thing. So key thing, check for number of gas molecules on each side, because they're the most significant. They have the higher entropy. So check the number of gas molecules and also check for the total number of particles. Normally it's an easy judgment to make. If it's hard, they'll get you to do the calculation. So let's do a couple of examples. Example number 1, we will go back to our magnesium carbonate solid becoming magnesium oxide solid plus CO2 gas. Is my entropy increasing or decreasing?
Increasing.
Increasing. Increasing why?
There's a gas.
Fabulous. And there's a gas and also
2 particles.
1 particle becomes
2.
2 particles. So for this one, my entropy is increasing because 1 particle goes to 2 particles, 1 of which is a gas. So 1 solid particle becomes a solid and a gas particle. So in summary, 1 solid particle goes to 1 solid plus 1 gas. So that's a double whammy. The universe is happy. My entropy from going from there to there is increasing. Example number 2, let's go back to do this one here. CH4 as a gas plus 2O2 as a gas goes to CO2 gas plus 2 H2O liquid. Right.
Okay, Brian. Decreasing.
My entropy, let's have a look. On this side, I have got 3 gas molecules. On this side, I have 1 gas and 2 liquid molecules. So, my entropy for this reaction is decreasing.
This liquid is less than gas, right?
Yeah. Entropy is decreasing. So, remember these were the 2 examples we looked before. They're based on enthalpy, energy, we thought this one would be really good to go, and this one wouldn't. But actually, when we look now at entropy, the reverse is true. That in terms of entropy, the universe is not happy that this is occurring, because I've got 3 gas molecules becoming a gas and 2 liquid, which are far more ordered.
So when the universe isn't happy, does it do anything?
The reaction won't happen.
So it won't happen naturally?
It won't happen, no.
At all?
Normally, that's all you have to do. However, sometimes you have to actually calculate a numerical value. Here we go. This guy here, I've got a solid becoming an aqueous solution. That's going to be increase. So that's going to show an increase. What about this guy here? 3 gas molecules becoming 2.
Minus.
Yeah.
And it's also because there's less particles.
Yeah, absolutely. Right, this one's a little bit tricky, but you've got to focus on your gas, guys. So I've got 12.5 gas molecules becoming 8, so it is decreasing as well, negative. Okay, so next lesson we will put some numerical values on these.